So what I want you to do is draw this triangle in your notes. We have been talking about the trig functions just using like ordered pairs on an xy axis. But we're also just going to see them a lot of times in a picture. We might have a triangle and we'll need to be able to evaluate the trig functions in that picture. When I'm looking at this, the angle matters. So I told you before, like if you had sine, I wanted you to write sine of theta, cosine theta. I didn't want just sine equals something. Because what happens is if I'm looking in this picture, sine from angle A is different than sine from angle B. So the angle matters. Our trick to remember this, we're going to use SOHCAHTOA. You can write this down in your margin or something. So SOHCAHTOA will help us with this definition. From my triangle, a notation that we use a lot in geometry and will continue here, we use capital letters for the angles. And then the side opposite, we do a lowercase letter. So if this is capital A, side A is across from it and it's lowercase a. Angle B is up here, so side B is at the bottom. Side C is across from angle C. So sine from angle A. So sine is opposite over hypotenuse. So from angle A, this is why the angle matters. The opposite side is side A. Opposite means across from. Over hypotenuse is across from the right angle, so that would be C. What if I were looking at angle B? What would my opposite side become? If I were up here, my opposite side is E now. So that's why the angle matters. Cosine, ca. Cosine is adjacent over hypotenuse. Adjacent means touching. Now technically there are two sides that touch angle A. The adjacent side is going to be the side that is not the hypotenuse. So the hypotenuse is always across from the right angle, so my adjacent side here is just B over hypotenuse, which is C. Tangent, TOA. Tangent is opposite over adjacent. Okay, so from angle A, the opposite side is side A. The adjacent side means touching it, but not the hypotenuse, so that would be B. So SOHCAHTOA gives you a trick for memorizing sine, cosine, and tangent. How can we get the other three? They're reciprocal. So cotangent is the reciprocal of tangent, so it would be adjacent over opposite. Or the reciprocal of my A over B would be B over A. Secant is the reciprocal of cosine, so that would be hypotenuse over adjacent. Which is C over B in our picture. Cosecant is the reciprocal of sine, hypotenuse over opposite, which is C over A. Any questions for me? So for all of these problems that I'm going to do today, I have an example and then I have another example ready to go if we need it. So we'll do one and then you guys tell me if you need a second one like it. Here is our first example. Triangle ABC is a right triangle with angle C equals 90 degrees. You can write that down if you want. It's pretty much going to be the start of every problem. C is always going to be our right angle just to be consistent. So we need to know side A equals 6 and side C equals 10. So you can either write the problem or draw a picture and label it. So C is the 90-degree angle. A and B are just the other two. The most common mistake here is in labeling. If A equals 6, where would I put that? It goes across from angle A. So in my picture, it would be on the bottom. C equals 10, that's across from angle C, so that's the hypotenuse. I need my other side. How can we get that? Pythagorean theorem. A squared plus B squared equals C squared. So my A was 6. We don't know B. C is 10. Now the problems we were doing before, when we did the square root, we had to think about whether it was positive or negative because of our quadrant. If you're talking about a triangle, will you have a negative side length in a triangle? No. So my B is just a positive 8. So there is my triangle. Okay. I want the 6 trig functions of A. You have to watch this. I might say A, I might say B. I will never do the right angle. This triangle definition does not work for the right angle because in that case your opposite side and your hypotenuse become the same thing and it doesn't work. So that's why we had to have the x, y, and r definition. So on these I'll either ask from A or B, one of the acute angles. So sine of A. SOHCAHTOA. Sine is opposite over hypotenuse. I am viewing everything here from angle A. So from A, my opposite side is 6. My hypotenuse is 10. Lowest terms, that would be 3 over 5. I don't want decimals, keep it in fraction. And then if I know sine, that automatically gives me cosecant. They're reciprocals, so cosecant would be 5 over 3. Cosine A. So cosine, adjacent over hypotenuse. So from A, the adjacent side is 8. It's the side touching it, that's not the hypotenuse. Over that hypotenuse, which is 10. And that reduces to 4 over 5. So that means secant, the reciprocal would be 5 over 4. Tangent, TOA, tangent is opposite over adjacent. So it would be 6/8, which is 3/4. That means cotangent is 4/3. Is that one all right? Let me give you one. Let's say we still have a triangle ABC. Let's say side B is square root of 5 and C is, let's see, I guess it doesn't have to be pretty, does it? Square root of 21. Let's do some radicals. Throw those in there and see how you do. So, you'll have to draw your triangle. I want the 6 trig functions from angle B. So C is the right angle, side C is radical 21, side B radical 5, A squared plus B squared equals C squared. You guys all did this correctly. So A is 4. So I think we all got that. I want the trig functions from B. So sine of B, so I'm looking from down here. So my opposite is radical 5, hypotenuse radical 21. Get the radical off the bottom. If both of these numbers are under the radical, you can multiply them together. And that's a 105 over 21. You have to check to see if 105 is divisible by any perfect squares. It is not, so that's your final answer. Cosecant is the reciprocal of sine, so it would be radical 21 over radical 5. You multiply by radical 5 on top and bottom. You get radical 105 over 5. Cosine, adjacent over hypotenuse, so 4 over radical 21. Multiply the radical. Since the 4 isn't under the radical, it stays outside. So it's 4 radical 21 over 21. So secant, the reciprocal, would be radical 21 over 4. Tangent, opposite over adjacent, radical 5 over 4. So cotangent, if you flip it, you should get 4 radical 5 over 5. Okay, that was probably one of the ugliest ones I can give you as far as simplifying those radicals. Do we do okay?
Yep.
Looking at, when I was walking around, you guys seem to have a really good grasp on that. So, I am going to move on to the next piece. We also want to talk about cofunctions today. So this tells us something about our trig functions. They're equal, cofunctions are trig functions that are equal when their angles are complementary. And the cofunctions, sine goes with cosine, tangent and cotangent, secant and cosecant. This is different than reciprocals. Reciprocals, when you have one, you can flip it to get the other. Cofunctions, when their angles are complementary, the functions themselves are equal. What that means, since sine and cosine are cofunctions, that's like saying the sine of 30 degrees is equal to the cosine of 60 degrees. They have the same value. want to fill in the blank. Make this a true statement. Sine of blank equals the cosine of 33 degrees. Sine and cosine are cofunctions. That means they are equal if their angles are complementary. All I really need to do is find the complement of 33. Or if you like variables, you could think of this as an x for a minute. If they're complements, that means x plus 33 has to equal 90. So x would equal 90 minus 33, 57. So the sine of 57 degrees is equal to the cosine of 33 degrees. Okay, second one, tangent of y equals cotangent of blank. So again, we just need to complement. If you called this an x, if you want to set up an equation, it means y plus x equals 90. So if you're solving for solving for x, subtract your y, it's just 90 minus y. What would c be?
15.
The complement of 75 is 15 degrees. Is that okay? Do one more example using this. So I want a solution to this. I want to solve for theta. Cotangent of theta minus 8 degrees equals tangent of 4 theta plus 13. If I want theta, what's true about tangent and cotangent? Right, they're cofunctions, so if they're equal, that means their angles add up to 90. So that means 5 theta plus 5 equals 90. So theta is 17. Do we need another one like this? I mean, I have a part B if we need it. Or do you understand those? It's not hard, but I have found people just tend to forget about cofunctions. So just remember they have to add up to 90 to be equal. The last thing I want to do today is to kind of set us up for tomorrow. We're going to have certain angles that come up a lot. Two of those angles are 30 and 60 degrees. So if we had, I gave you a 30, 60, 90 triangle here, and I have given you side measurements, okay? I want to find the 6 trig functions of the 30-degree angle in this triangle. So we're going to find the sine of 30 degrees, cosine of 30, So from my 30, sine is opposite over hypotenuse. So the sine of 30 is 1/2. That means cosecant of 30 would be 2 over 1, which is just 2. Cosine of 30. So from my 30, my adjacent side would be radical 3 over the hypotenuse, which is 2. Secant, if I do the reciprocal of that, we get 2 radical 3 over 3. Tangent of 30. TOA, opposite over adjacent. 1 over radical 3. What does that turn into? And cotangent of 30 would be radical 3 over 1, which is just radical 3. Okay, we are eventually, these values come up so much, we are going to have to memorize them, but tomorrow I am going to give you a ton of tricks to do that. So just looking at it right now, it just seems overwhelming, but I will give you some tricks and show you some patterns tomorrow to make that easy. The second angle we will use a lot of is the 60. So let's go ahead and just write down the 6 functions for 60. So that changes my viewpoint. Now I'm looking from down here. So the sine of 60. So sine is opposite over hypotenuse. So that would be radical 3 over 2. So cosecant would be the reciprocal. You get the radical 3 off. You get 2 radical 3 over 3. Cosine, adjacent over hypotenuse. From cosine, or from my 60, my adjacent is 1, hypotenuse is 2. Secant then would be 2. Tangent from 60, TOA, opposite over adjacent, radical 3 over 1, which is just radical 3. Cotangent would be 1 over radical 3, which is radical 3 over 2. Remember, sine and cosine are cofunctions as well. Look, the sine of 30 and the cosine of 60 are the same. Cosine of 30, sine of 60 are the same. So our cofunction values work there. Any questions on that one? Okay, trying to decide. There's one more special angle. I can either do that one now, or I can just stop and give you the first little bit of homework from this section. Can I do the last one? Last special angle, is that okay? Why
Yes.
not? Okay.
Find out where we go.
The next special angle is 45. So if I were talking about a 45-degree angle, what's the other angle in this right triangle have to be? 45. Okay, I didn't give you the original triangle this time. We have to kind of come up with it. If these angles are the same, that means the sides have to be the same, so we can pick any number as long as they're both the same. So let's just do 1 for both of them. Then we can do Pythagorean theorem to find the hypotenuse. 1 squared plus 1 squared equals c squared. So our hypotenuse is radical 2. Okay, So sine of 45, you can look from either one of those 45-degree angles. We're going to get the same ratio. Let's just look at the bottom one here. So sine is opposite over hypotenuse. So 1 over radical 2. Get the radical off the bottom, you get radical 2 over 2. And that means cosecant, the reciprocal of sine, would be just radical 2. Cosine of 45. So from this 45, cosine adjacent over hypotenuse. So 1 over radical 2 again, which gives us radical 2 over 2. That means its reciprocal secant would be radical 2. Tangent, TOA, opposite over adjacent, 1 over 1 is just 1, so cotangent of 45 is 1. So tomorrow I'm going to start with a lot of tricks for how to learn these values and make it a lot easier. Are there any questions on how I came up with those? That is our stopping point for today. I'm going to give you the first bit of homework. I'm not collecting this tomorrow. I'll probably just add to it. There's a big matching section in this, and those last couple examples we did will help you with that matching. And there's quite a few questions on the cofunctions, which should go pretty quickly. So you've got some time.